Yeah, I'm going to talk a little bit about HPE and our role in the OpenCHAMI community and development, kind of our goals and where we see things, where we'd like to see things going. So we want to contribute to the core services to make OpenCHAMI usable and reliable. We want to build interoperability and compatibility with other proprietary software that we at HPE have. And we want to help to support the OpenCHAMI community by contributing resources and effort for things like automated testing, CI/CD. And then lastly, the hope is to be able to integrate the resulting OpenCHAMI services that the community develops into other higher level HPE products for system management. So on the development side, we've been doing that by working with the community to develop additional services based on Fabrica. That got a little garbled there, but contributing to those shared libraries and projects that Fabrica, you've heard mentioned quite a few times already, and just generally being good citizens in the project, responding to issues and reviewing PRs, and then the development of new core services. So SMD was mentioned before, and there was some discussion about X names. One thing that might be pertinent, or that is pertinent there, is a rewrite of SMD, which we've imaginatively called SMD2. It's based on Fabrica. It preserves the compatible API with the original SMD, and it's not yet in the OpenCHAMI org. We're working on a prototype first, and there will be an RFD to follow, where we can, as a community, decide what to remove, keep, or additionally add to it. The Fru Tracker, which Ben presented yesterday, and there will be some more discussion about that tomorrow, I believe. And that provides the inventory API for OpenCHAMI, again, generated with Fabrica. There's also a nice blog introduction that Ben did. We'll figure out some way to share these slides with the links, but you can find everything on the openchami.org website if you poke around a little bit. One that is under development, again, there isn't a public repo on the OpenCHAMI organization yet, but we're working on a firmware management service that would replace FAS from CSM. It doesn't share any code directly from that. Right now, it targets Redfish-only firmware updates. Architecturally, it's a separate library service and update service, and distinct from previous firmware management efforts. The device-specific details are in configuration, not in code. So it's decouples the release of new versions of the firmware management service and some of the particulars for individual devices. We're working toward compatibility. Some people have used CSM in the past and want to move to OpenCHAMI. We want to help make that as easy as possible. So Alex talked about the EX Bootstrap. There's a tool that we've developed, which is open source. It's available there from the Cray HPE GitHub site called CanI, and it seeks to ease the interchange of inventory data between alternate system management software packages using a standard format for that interchange that is shared by Netbox, not a bot. In the OpenCHAMI, again, kind of supporting the community, we are working on automating CI/CD integration tests for OpenCHAMI. There's a related project called VTDS, Virtual Test and Development System, I think. And there's a blog post that the developer, Eric, put there. This was from the last Dev Summit in Austin. And so we're going to be working to integrate that so that we can do testing under VTDS of all of the OpenCHAMI services from a release working together in GCP. Some activity that we've done in the community, some publications, mainly from Ben and Alex, here at HPSF, and then at PERC. And then there's the upcoming Developer Summit in the UK at UCL, in University College London in May, and then the ISC BOF. So you'll note from my initial goals that I didn't have a specific slide of ways that we've integrated OpenCHAMI into HPE products yet, but that is where we're working. So whirlwind tour, any questions? I'd be happy to. Yeah, Alex or Travis, fight for it, guys.
So SMD2 mentioned the XName stuff. I haven't had a chance to look. So has Shane got an opinion on where to go post XName?
So the question was, what direction are we going with SMD2 with regard to XNames? The answer is Shane has opinions about that, but has not decided on a direction yet. So that is something I was talking to John about yesterday, that now is, I think, the time to make that decision. He will be pulling that into the OpenCHAMI GitHub organization soon. Right now it's in his private, or his personal GitHub, but he has worked through the version of SMD2 passes all of the tests that we have, so that it behaves like SMD. So at this point, we can then make decisions about how it should diverge from that. Travis?
Can we not call it SMD2?
So the request was, can we not call it SMD2? The answer is sure. What would you like to call it, Travis?
Oh, don't ask me. I already did.
Yeah, obviously, we're very open to any alternative name for it, but yeah, Devin.
Can you comment on how similar or different the API for SMD2 is from regular SMD?
Right now, the question was the comment on how similar the SMD2 API is to the original SMD. Right now, it is API, like the exact API. If we choose to diverge from that, which I think we may want to, that would be a deliberate decision that we'd have to make together. But right now, it was, what Shane was working on was a proof of concept of implementation for SMD2 using the database backend for Fabrica, which I don't think other Fabrica-based services have used, right? The relational database backend. So there were some other things, just kind of technical implementation details that Shane wanted to work through. So we are at a starting point where we can use this to extend, bring features into SMD2, or whatever Travis wants to call it, or take out of SMD2.
Okay, so it's meant to be basically like an API compatible implementation using Fabrica essentially of SMD.
Right now, yes. Right now, yeah.
Thank you.
Okay, thank you. The microphone is still on.
Thank you.
Here is the.
All right. See if we can make this work. That was a cool feature. As soon as it connected, it closed my PowerPoint.
I didn't want to share your secret.
So we have been rather busy, I think, with the OpenCHAMI project, and I think Jay and I have a lot to talk about building systems and building, I think, products around OpenCHAMI. Almost 6 years to the date, March 25th in 2020. my colleague Luke Wilson and I checked in the 0.1 version of Omnia to GitHub against the Dell's will until we got them convinced that it was a great idea to be able to publish these things online and publish them under an open source license. Getting the corporate world to understand that we can contribute to open source and benefit from our contributions to open source isn't the easiest thing, but it's something that we've succeeded in, I'll say. Like I said, it was a long time ago. We were just working in the engineering lab, building really proof of concepts, doing benchmarking, performance evaluation. We had a whole team of folks that were doing all sorts of different GPU setups, different network setups, and really they were just building Slurm and Kubernetes clusters. They were trying to deploy MLOps platforms, or they were just doing performance evaluation with Slurm. And so we were taking what we called piles of metal, switches, and sometimes a storage device, and really just creating simple Ansible workflows that would tie these all together to build simple clusters that we were comfortable with, right? A login node and some computes, a standalone Slurm controller, or some variety of Kubernetes environments that were just simple to get people started. And it was cool. We were just kind of building on best practices, getting stuff out there, and it worked. It accelerated a lot of what we did inside of the lab. Some people really liked it a lot and wanted to build more out of it, and so we did continue to build off of where we started, and actually have a team of about 15 developers that work on this full time. And we have a system using Omnia today that wraps around OpenCHAMI for managing our large-scale systems that we're deploying. Doing full-scale system management, whether you're kind of having that view of, are you a system administrator, are you a network person, are you creating user environments, or are you the facilities person? Because our racks, like Jay's racks, they all look a lot more complex. They're not just compute. They're cooling. They're power distribution shelves. They're all sorts of very cool new things that it's very easy to, I'll say, automate as we can do quickly with new things, and wrap these all up into large scale systems. So we're still focused on deploying basically logical partitions of Kubernetes and Slurm-based systems, whether they're just one large-scale system or kind of piecing them out based on projects or departments or things like that. Mixed environments, whether that's ARM-based, x86, NVIDIA, AMD. We like to look at them all. And again, like I said, the way we do that is we wrap around OpenCHAMI. We've been around, again, for a long time now. When we started, we used Cobbler. I think we were one of the early projects that tried to containerize Cobbler, and that was fun. And we left that alone and moved to XCAT, and went for something that was a little more stable. And then they disappeared. And I'll say that OpenCHAMI kind of turned up at the perfect time, right? It was the perfect time for a new open source project around provisioning and image building. There weren't a lot of other good tools, I think, when that started, and I think we liked that as well, because we said, well, we're not going to do XCAT and we're not interested in Confluent. What else would we do? Well, this is kind of building upon what we've been building inside of Dell, of helping them contribute to more open source projects, and showing how we can tie them together with the things that we're doing as well. We also really like the idea of doing quadlets, like Alex talked about. So we have what we call an infrastructure manager system that we deploy as quadlets, a GitLab environment, the OpenCHAMI entire piece there, pulp for a container repository, and all of our Ansible automation happens inside a single server deployed as systemd services. So super cool as a single node. If you want to make it HA, today we're just doing like a pacemaker and CoroSync, and you can mirror as many of those as you want, which makes most people happy. We've done this with a Kubernetes system as well, which makes less people happy. So we tried to be flexible in how to do that and make this maybe a little more lightweight. Although we tie into like storage platforms, like I said, I mean, Dell is a storage company, so we do tie into those when we can, but they're not required. The installer for the Omnia infrastructure manager will work on a single server. It'll ask you if you have an NFS export. If you don't, it'll make one, and it's not performant, but it's good enough to test and get you going. And then what we build off of that is this is sort of our bootstrap server. We'll take that and start to build what we'll call a full system, which is more of, sometimes we have some bare metal and VM appliances that still exist for, things like managing, I don't know, third-party power shelves or third-party things. So I still see sometimes I have bare metal like compile nodes over here where I'm doing constant OS image building and testing. So a couple of those pieces, and then we'll build out a service cluster that we call fully Kubernetes system where we start to deploy all of those other like telemetry collection services, all of the other stuff that the rest of our customers are interested in seeing, or the tools that are needed to run the rest of that system. And then network and storage on the bottom, of course, always important. All right, so what have we done with OpenCHAMI specifically? We are doing some RHEL 10 provisioning, kind of what Alex had alluded to. We do some role-based node classifications for our system. So we have Kubernetes control planes, workers, service node, Slurm controllers, compute nodes, and then login nodes, compiler nodes. There's data movers. There's a few more in there that I don't think are not listed. And then we will we create an image for each of those roles. We create a base image using the image builder tool today with Builda, and then we create we add add-on packages for each of those role-specific images. So GPU drivers, specific InfiniBand, Broadcom, those sort of things. And we're doing like some hardware-aware provisioning with PowerEdge stuff, where I think we'd like to do a little bit more with Magellan and SMD2, the tool formerly known as SMD2. One of the other projects that we're doing, and I think that's good that Alex brought that up, is around the image builder. We're building just basically some CI/CD pipelines, some Git runners around the image builder itself to automate those images that I talked about previously, and automate like a testing suite so that we can run some basic functional tests, boot them up, and do some sanity testing with those as well. Today we're using a remote host to build our like ARM images, and I think we've started to look at some other ways other than Builda, and this just seems that the only problem there is Builda does all emulation when you're cross compiling, so it doesn't do any cross compiling. I'll put it that way, and it's incredibly slow. So I think that's another piece that while we have a nice pipeline and these Git runners are out there already on our GitHub that you can go check out. That's something we'd like to continue to work on too, which I'm seeing lots of nodding and people in agreement with that. Up next for us is we still have a few customers that are tied to stateful deployments, and so I've started to think about some ideas about how to maybe template out some easy starter pieces for what we can say. Oh, maybe that we're just doing some NVMe drives. Maybe we're just doing M.2 sort of systems, making something simple. I need to start an RFD for that. We're currently with Omnia not doing a whole lot of auto discovery. We're just using a mapping file. As Alex described, just shoving it in there and saying, hey, this is what our system looks like, and we'll change it with, we're managing that inventory inside of our Git configuration, rather than, and then pushing those configs to SMD and BSS, and I'd like to turn that around a little bit more. That's also kind of what we're doing with that image builder process, is we've kind of left it open of, well, sometimes people like to do stuff in post with Git, with the Cloud init scripts, and all of our stuff previously was Ansible post configuration, right? We used to just boot very minimal images and then do everything in post. It's nice to have both and allow customers to choose, hey, I want those pieces in my image, or I never want that in my image because I think it's always going to change. Interesting pieces to like to let people decide. So I kind of like how it is today, and I think it can still get better. We're also really interested in fruit tracking. We don't tie in with that. I think we'd like to tie in with like how to tie in with like physical lockers, how to make it easier for folks on the floor to replace those and track that easier. We're also, like I said, on GitHub. We're still out there if you can come find us. We also love comments and issues and people who like to yell at us, and we do respond to good questions. Still planning to do quite a bit more with OpenCHAMI. Said really like the project as it is today, and I think we sit on the technical steering committee as well as the advisory board, and I think that together we can continue to build things that are mutually beneficial to all of us. Really to put these kind of tools out in the open and make it less scary for people to build HPC systems. Questions?
You mentioned that you've got on GitHub the runners that you use to build images. Is that on the Omnia side, or is that in the OpenCHAMI side someplace?
It's on the Omnia side today. Yep. So we've got a release candidate tagged that has those Git runners in there that I can point you to.
It would be great if you were to blog about that, so that we want our community to be able to find things that aren't necessarily in the OpenCHAMI repos, because we're starting to see more people using OpenCHAMI with other tools. So that'd be a way for people to see your work and kind of head in that direction.
Yeah, absolutely. Question.
Yeah, I was wondering, maybe I missed this, but it sounded like you guys do have some active users in Omnia, and I'm just curious if you could talk about like how Omnia is being used today and like what your ideal end goal, like end state is of Omnia for you guys.
So the question is, how is it being used today, and where do we see it going? Honestly, I see a lot of the actions that we do today being able to be contributed into the OpenCHAMI project, because we did not a lot of magic, a lot of just tying all the tools together and really deploying them. Some of them don't make sense to deploy to put into OpenCHAMI. Like I don't think it makes sense to say, hey, every customer is going to want a GitLab and a pulp instance, right? They maybe have their own choice about how they serve up binaries. So I think it's just kind of finding those places where we can just give what we have already put out there and say this is a great piece for the OpenCHAMI community to use that maybe we don't have to do custom one-off in the Omnia project.
But I guess like independently of OpenCHAMI, like Omnia itself, like how is adoption and usage of Omnia, I guess, is more relevant.
Sorry, say that again.
Like independent of OpenCHAMI, I'm just curious, like the Omnia's usage more broadly.
How is its usage?
Like what kind of users do you guys have
Today,
today?
large-scale deployment system, so labs, mostly is where we see the deployments. Question.
Yeah, John, I think I'll maybe relate it to Ben's question. You led off talking about how you have logical partitions.
Yeah.
In a machine. I'm wondering if how important it is in your roadmap for your customers to have like hard network isolation, hard multi-tenancy within a system. If that's something that you see being tractable with Omnia, or like how, well, yeah, basically.
Yeah. The question was about partitioning and how we do logical. Do we see anything beyond that? I definitely hear that from customers that they want more multi-tenant and the ability to do that. I think today when we often look at what we're building, they're like NVLink based, InfiniBand. does that make sense? Is that possible? I think are good questions. Maybe. I think we looked at it as logical was the easy answer. Obviously, it's not the most secure answer. But I definitely have come across several customers that want more ability to do that on the fly and be more cloud-like. And I think I was discussing it with some folks, and we were talking about, well, I mean, there is OpenStack. Would we just be recreating OpenStack in that sense? And if so, I don't want to do that. If there's OpenStack, you can buy OpenStack, right? That's I don't know. That's a tough one on where to draw the line there, because we're still really, again, focused on building just really the biggest systems that people want to build, whether for science or their AI world. Yeah, of course.
So it's kind of weird to see you using Image Builder just from I wrote that as a necessity and then was forced to open source it. And I have other words that I don't think I want to say about it. I will over a beer if you want later. But so the pipeline stuff is pretty cool. We did something internal on my own with pipelines. We did with GitLab. And we're definitely still improving on it. But the ARM question has come up a lot. And yeah, if you try to emulate it, it's like hours. And our solution was to like just make a runner on an ARM box so that we didn't have to do that. So I was curious about like what if you weren't going to use Builder, like what would you use?
That's a great question, because that's what we're doing right now. Is we're doing the same thing. We have an ARM box that that's where we're running those build processes. I think that I like using Builder because it makes the user-based containers and it's one tool to do everything. I think is why I like that. If I wasn't going to do that, I think I would have to use another tool to build the images themselves, right? And basically split out the. You can cross-compile most of the beginning of the image, but the actual the kernel piece that actually needs to be emulated with that 40 megabytes, that you can do in emulation. As long as you do everything else with a cross-compile, it's pretty fast. And I talked to some engineers in Dell who've done this. We had a project where they were working on edge-based systems, which were all ARM. So they sent me a couple of ideas to look at this week that I can share with you too. That's really just kind of breaking apart the image build, but allowing you to cross-compile it and still do it in a reasonable speed instead of 20 hours.
I mean, would there be interest in like updating the image build tool?
Yeah, I mean, yeah, because today we're just, users of it, and we would like to be able to help on that side. Yeah. And I mean, if we're stuck on Builder, that's okay, and maybe we can work with that. But if that's it's one of those, like, I feel like it's a decision where, like, it was there and it works really great.
And it's a Python wrapper, so.
Yeah, exactly.
Cool.
Yeah, so something for us to work on.
I mean, it's cool because I don't think I've ever built a Rel 10 image with it, so I'm glad it worked.
It does. It does. It works great. We're always here to test something for you. Maybe we should let you know more when we do get it working. All right, thanks.
Thanks, guys.